This is a video lecture for Math 110 for Friday, April 24th. This is part one of the video lecture. And the topic today is the law of cosines. Now we've talked about right triangles and how to solve right triangles using the Pythagorean theorem and using the sine, cosine, and tangent trigonometric functions. And then we talked about a situation where you have a non-right triangle and how we can solve that. And we use the law of sines to solve some non-right triangles. Well, what if today we're given this triangle? Could we solve this triangle? Obviously this is a non-right triangle, but could we solve this triangle using the law of sines? And the first step here is to label our sides and angles. So I'll label this angle A. This is side angle B. This is angle C. So this is side A. This is side B, and this is side C. And we can try to use the law of sines to solve this triangle. Now notice in this triangle, we know one of the sides, we know another side, and we know the angle between those two sides. So if we try to use the law of sines, for instance, we could write A over sine of angle A, which is 115. Okay, and we could set that equal to another angle pair, such as B and side B. So this would be side length B is 18, and this would be sine of angle B. We could also do this for C, so we get 30, which is the length of side C, divided by sine of angle C. So this is what happens when we use the law of sines in this triangle. Now we have a problem here, because whatever pair we use here, whether we use A and B, B and C, or A and C, whatever pair we use to try to solve this triangle, we're always going to have two unknowns. If we use this pair, we don't know side length A or angle B. If we use this pair, we don't know angle B or angle C. If we use this pair, we don't know side length A or angle C. So we can't actually use the law of sines to solve this triangle. And so we need a different law to solve this triangle, and that's where the law of cosines comes in. I'm going to write down the law of cosines for you. And what it says is a squared equals b squared plus c squared minus 2bc cosine of angle A. This is the law of cosines. Now we derive the law of sines. We're not going to derive the law of cosines because it's beyond the scope of this course, but we are going to use it. And there's actually three other versions of the law of cosines, but the good news is they're all the same law, just applied to different sides of the triangle. So this is a law of cosines applied to side A. We could also apply the law of cosines to side B and C, and that would look like this. B squared equals A squared plus C squared minus 2AC cosine of angle B. Or we could apply it to side C. C squared equals A squared plus B squared minus 2AB cosine of angle C. These are all the same law. They're just applied to different sides. And you actually, once you know one version, you know the other one, because all we do for the second version here, all we did was switch A and B. For the third version, we just switched A and C. So these are all the same law, but we can apply them to all three sides of a triangle. And these are very useful equations. I want to state this in words. So, it's beyond an equation, so it'd be nice to know what this means in words. What this is saying is if you have any triangle, the square of the length of one of the sides equals the sum of the squares of the lengths of the other two sides minus 2 times the other two sides multiplied together times the cosine of the angle opposite to the first side. That's kind of a mouthful, but that's in words what the law of cosines says. By the way, you won't have to memorize the law of cosines. I will give that to you on an equation sheet, but you will need to know how to use it. One thing I want to do now is I would like to apply the law of cosines to a right triangle and show you guys something neat. So let me do that. I'm going to erase this here, and I'm going to draw a right triangle. So if we have a right triangle, it looks like this. Recall a right triangle is a triangle where one of the sides has a right angle. And let's label this triangle, the sides here, A, B, and C. And that means this angle is angle A, this is angle C, and this is angle B. Now you might wonder, why would I ever want to apply the law of cosines to a right triangle? Because right triangles we already know how to solve. We don't need the law of sines or cosines to do this. But I do want to show you something neat. If we try to apply the law of sines to this triangle and apply it to the side A, we get A squared equals B squared plus C squared minus 2BC cosine of angle A. And we just talked about this law. For a right triangle, angle A is equal to 90 degrees, as we talked about. And the cosine of 90 degrees, you guys can check this in your calculator. The cosine of 90 degrees is actually 0. This is 0. And what that means is this part here goes away, because this is just 0, because the cosine of angle A is 0, because A is a 90 degree angle. And so what we have here, so this equation reduces to A squared equals B squared plus C squared. If we apply the law of cosines to a right triangle, we simply get A squared equals B squared plus C squared. Well, what is this? This is actually the Pythagorean theorem, which we learned about earlier. And so the cool thing here is if you apply the law of cosines to a right triangle, it reduces to the Pythagorean theorem. But in practicality, we never would want to apply the law of cosines to a right triangle because we already know how to solve a right triangle without it. Well, we want to apply the law of cosines to non-right triangles. And in part 2 of the video lecture, I'm going to do 2 examples where we use the law of cosines.